Have you ever sat in a quiet room, perhaps late at night, and simply listened to the silence? If you listen closely enough, beneath the settling of the house and the wind outside, you might hear the rhythm of your own heart. Thump, 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 thump. It is the most primal clock we know, a metronome that has been ticking since before you were born, marking the passage of moments in a steady, relentless drumbeat. We feel time in our bodies. We feel it in the heaviness of our eyelids as the day ends, in the hunger that returns like a tide, in the slow, graying changes we see in the mirror over the years. To us, to be human is to be submerged in a river that flows in only one direction. We remember the past. We experience the present. We anticipate the future. It seems so obvious, so undeniable. The river carries us forward, away from our memories and toward our destiny, and we cannot swim upstream. We cannot go back to correct a mistake or relive a perfect afternoon. The flow is absolute. The flow is real, or so it feels. But what if I told you that this river is an illusion? What if the sensation of flowing time, of a now that moves from yesterday to tomorrow, is a trick of the mind, a biological adaptation that hides the true frozen nature of the cosmos? Imagine for a moment that you could step outside of your life, outside of the universe itself, and look at it from a distance. Would you see a movie playing out, frame by frame, or would you see a solid block of crystal where the beginning and the end exist simultaneously, frozen in an eternal, changeless sculpture? The question of what time actually is has haunted philosophers and scientists for thousands of years, but in the last century, our best physics has torn apart our intuition. We have learned that time is not a steady drumbeat shared by everyone. It is not a universal container that things happen inside. It is something far more strange, far more malleable, and perhaps far more illusory than you ever dared to imagine. As we embark on this journey into the deepest fabrics of reality, we must first be willing to let go of everything we think we know about the ticking clock. I am Walter, the Explorer, and I want to welcome you to this quiet corner of the internet where we explore the biggest questions in the universe together. I have noticed that about 73% of the people who join us on these journeys have not yet subscribed to the channel. If you find peace and wonder in these explorations, and if you want to help us keep asking these questions, please take a moment to subscribe. It truly helps us continue this work, and I would be honored to have you as a permanent companion on this voyage. Now, let us drift back into the river of time. To understand why physicists question the flow of time, we must look at how the universe handles the concept of now. In our daily lives, now feels universal. If I snap my fingers and you snap your fingers at the exact same moment, we agree that it happens simultaneously. We imagine that there is a giant cosmic clock ticking away in the background of the universe, setting the time for every star and every galaxy. But in 1905, a patent clerk named Albert Einstein shattered this idea forever. He realized that time is not absolute. It is relative. It depends on how fast you are moving and how much gravity you are feeling. This was not just a philosophical trick. It was a physical reality that has been proven by experiment after experiment. Consider a beam of light. Light travels at approximately 186,000 miles per second. That is fast, but it is not infinite. When you look at the moon, you're not seeing it as it is now. You're seeing it as it was 1.3 seconds ago. When you look at the sun, you are seeing it as it was 8 minutes ago. If the sun were to suddenly vanish, we would not know. We would not feel a change in gravity. We would not see the darkness. for 8 whole minutes. We live in the past of the things we see. But Einstein went further. He showed that the distinction between past, present, and future depends on your motion. If you and I are moving at different speeds, we will not agree on what now means. Events that I see happening at the same time might appear to you to happen years apart. This leads to a concept that physicists call the block universe. Imagine a loaf of bread. You can slice it vertically, and each slice represents now for a stationary observer. But if you slice it at an angle, you get a different cross-section of the bread. In the block universe, all of space and all of time, from the Big Bang to the heat-death of the universe trillions of years in the future, exist already, like that loaf of bread. The dinosaurs are still roaming the earth in their slice of the block. Your birth is still happening. Your death and the death of the sun are already there, frozen in the four-dimensional structure of space-time. In this view, which is supported by the theory of general relativity, the flow of time is just like the flow of a landscape outside a train window. The mountains do not move. The train moves. But in the block universe, even the train does not really move. The entire track, the train at the beginning and the train at the end, are just a static line drawn through the block. This is a terrifying thought for many. It suggests that the future is just as fixed as the past. It suggests that becoming is an illusion. Einstein himself found comfort in this. When his close friend Michel Besso died, Einstein wrote a letter to Besso's family saying, "Now he has departed from this strange world a little ahead of me." That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. A stubbornly persistent illusion. Let those words settle in your mind like dust motes in a sunbeam. The greatest physicist of the modern age believed that the passage of time, the very thing that drives our lives, our hopes, and our grief, is not fundamental to the universe. However, there is a problem. If time is a frozen block, if the future already exists, why do we feel the flow so intensely? Why can I remember breaking a glass yesterday, but I cannot remember fixing it tomorrow? Why do we see eggs shatter, but never see them unshatter and leap back into the carton? This brings us to the second great pillar of our understanding of time, entropy. While relativity tells us that time is a dimension like space, thermodynamics gives time an arrow. The second law of thermodynamics states that in a closed system, entropy, which we can think of as disorder or randomness, always increases. Things fall apart. Coffee cools down. Ice melts. Stars burn out. The universe began in a state of extremely low entropy, a state of high order, and it has been sliding toward disorder for 14 billion years. This increase in entropy creates the arrow of time. It distinguishes the past from the future. The past is the direction of lower entropy. The future is the direction of higher entropy. This is why we perceive a flow. Our brains operate on chemical reactions that generate entropy. We form memories by increasing the disorder in the rest of the universe. In a very deep sense, we are entropy machines. We consume order in the form of food and sunlight, and we excrete disorder in the form of heat and waste. The feeling of time passing is the feeling of entropy increasing. It is the feeling of the universe slowly unwinding. But here is where the mystery deepens, and where our journey will eventually lead us into the quantum realm. The fundamental laws of physics, the equations that describe how atoms bounce, how planets orbit, how light moves, are almost entirely time-symmetric. That means If you played a video of two billiard balls colliding, and then you played it backward, the backward video would look perfectly natural. The laws of physics do not care which way the clock runs. An electron orbiting a nucleus follows the same rules whether time moves forward or backward. So, if the fundamental building blocks of reality do not care about time's direction, where does the arrow come from? How do timeless particles create a universe that feels so obsessively focused on the future? We are left with a profound conflict. On one hand, we have general relativity, which describes a majestic, frozen space-time where the past and future are equally real. On the other hand, we have thermodynamics, which insists on a relentless march from order to chaos. And sitting quietly beneath them both is the quantum world, which we will soon see, treats time in an even more baffling way. In quantum mechanics, the theory that rules the subatomic world, time is often treated not as a thing that bends and warps, but as a simple background parameter, a stage upon which the actors play their parts. But when we try to combine these theories, when we try to understand what time is made of at the most fundamental level, we run into contradictions that threaten to break physics apart. Is time a fundamental field, like the magnetic field? Is it a granular substance, like sand, made of tiny discrete chronons, or units of time? Or is it something that emerges from a deeper reality, like heat emerges from the motion of atoms? Imagine a pointillist painting. From a distance you see a continuous image, a face, a flower, a river. But when you get close, very close, the image disappears. There is no face. There are only dots of color. Is time like that? If we look closely enough at the fabric of the universe, does time dissolve into something else entirely? As we lie here, contemplating these questions, try to visualize the universe without time. Imagine a vast, silent ocean of potential. No ticking clocks, no beating hearts, just existence, pure and absolute. In this timeless state, everything that can happen simply is. The story of the universe is not a book being written word by word. It is a library that has always existed. And we, the readers, are walking through the aisles, discovering books that were already there. This perspective changes everything. It changes how we view our lives. It changes how we view loss. If the past is still there, down the corridor of space-time, then nothing is ever truly lost. The moments of joy, the laughter of loved ones, the sunlight on a childhood garden, they are all still there, etched into the eternal block of the universe, as real as the chair you are sitting in right now. But we must go deeper. The block universe is a classical idea. It comes from a world of smooth curves and predictable paths. But our universe is not smooth. It is jagged. It is quantum. And in the quantum world, certainty evaporates. Particles can be in two places at once. They can tunnel through walls. They can be entangled across vast distances. How does time survive in a world where cause and effect can get fuzzy? How does the rigid structure of Einstein's space-time mesh with the chaotic foam of the quantum vacuum? This is the frontier. This is where the sleepy scientist must wake up and look into the abyss. In the coming chapters, we will leave the comfortable world of clocks and rivers behind. We will dive into the strange mathematics of quantum field theory. We will ask if time is a fluid, a crystal, or a hologram. We will meet particles that pop in and out of existence, borrowing energy from the future to pay for the past. We will explore the idea that time might be emergent, that it is not a fundamental ingredient of the universe, but a symptom of our ignorance, a shadow cast by our inability to see the whole picture. Let yourself feel the weight of these ideas. They are heavy, but they are also liberating. If time is an illusion, then the pressure we feel, the rush, the anxiety, the fear of running out of time is also, in a way, an illusion. We are part of a vast, timeless structure, intricate and beautiful, beyond words. We are the universe experiencing itself, slice by slice, moment by moment. And even if the river is a dream, the swim is still beautiful. As the stars drift overhead in the silent vacuum of space, remember that the light hitting your eyes has traveled across a void so vast that the mind cannot grasp it. That light is a messenger from the past, interacting with you in the present to create a memory for the future. But for the photon itself, the journey took no time at all. Birth and death, emission and absorption were a single instant. In the perspective of light, time collapses. Perhaps, if we could see the universe through the eyes of light, we would see the truth. We would see that time is just the way we make sense of the infinite. The journey we are about to take will challenge your intuition. It might make you feel dizzy. It might make you feel small. But remember, you are not alone. We are exploring this together, holding our lanterns up against the dark, trying to read the map of reality. And what we find might just change the way you perceive every heartbeat, every tick of the clock, every silent moment of the night. So, take a deep breath. Let the air fill your lungs and release it slowly. Feel the anchor of the present moment, however illusory it might be. We are here, we are now, and the mystery awaits us. Now that we have allowed the illusion of the flowing river to dissolve, we find ourselves floating in a different kind of space. Close your eyes for a moment and imagine you can zoom in past the skin of your hand, past the cells that knit you together, past the molecules of DNA coiled in the dark, and past the atoms themselves. We are going to a place that is smaller than small, a place where the rules of the everyday world break down and vanish like mist in the morning sun. We are entering the quantum realm. In our classical intuition, we tend to think of the universe as a vast, empty box filled with stuff. We imagine particles, electrons, quarks, photons, as tiny, hard marbles bouncing around in the void. We think of them as distinct little objects, like billiard balls on a cosmic table, moving through time and space. This is a comforting image. It feels solid. It feels like something we can hold in our hands. But the deeper we look, the more we realize that this image is not just incomplete. It is wrong. According to our most successful theory of physics, quantum field theory, there are no marbles. There is no empty box. Instead, the universe is packed full, brimming with invisible, fluid-like substances that stretch from one end of the cosmos to the other. We call these substances fields. Imagine, if you will, a vast ocean that fills the entire universe. This ocean is not made of water, but of potential. It is everywhere, inside you, inside the empty space between stars, inside the very atoms that make up the chair you are sitting on. This is the electron field. Now, imagine another ocean, overlapping the first one perfectly, occupying the exact same space. This is the photon field, the field of light. And there is another for quarks, another for neutrinos, another for the Higgs boson. We are living in a universe of layered oceans, dozens of them, all undulating and interacting in a silent, invisible dance. So, what is a particle? What is the electron that buzzes around the nucleus of an atom? In this view, a particle is not a thing. It is an event. It is a ripple in the field. Think of a calm lake. If you tap the surface, a wave travels outward. That wave is not a separate object from the water. It is the water itself, excited into motion. In the same way, an electron is just a localized vibration in the electron field. A photon is a ripple in the electromagnetic field. You, me, the stars, the galaxies, we are all just complex patterns of waves moving through these ancient, fundamental fields. We are music played on the strings of the universe. This shift in perspective is profound. It means that at the most fundamental level, there is no separation. The electron in your fingertip is made of the same field as the electron in a star, a billion light years away. They are connected by the same continuous fabric. But how does time behave in this fluid, vibrating world? In the classical world, the clock ticks steadily. But in the quantum world, time becomes fuzzy. It becomes uncertain. This brings us to one of the strange pillars of quantum mechanics, the Heisenberg uncertainty principle. Werner Heisenberg, a giant of 20th century physics, discovered that there is a fundamental limit to how much we can know about the world. We cannot know both the position and the momentum of a particle with perfect precision. But there is another version of this principle that applies to energy and time. It states that you cannot know the precise energy of a system and the precise duration of that energy's existence simultaneously. The more precisely you try to measure the time, the more uncertain the energy becomes. This has a staggering implication for empty space and for time itself. It means that zero is not really zero. If you try to look at a patch of empty space for a very short period of time, the energy in that space becomes wildly uncertain. It can fluctuate. It can spike. In the quantum world, energy can appear out of nowhere, borrowed from the bank of the universe, as long as it is paid back quickly. The shorter the loan, the more energy you can borrow. This means that the vacuum of space, the so-called empty void, is actually seething with activity. It is a boiling foam of particles popping into existence and then vanishing again before they can be detected. We call these virtual particles. Imagine the silence of a library. It seems quiet, still. But if you could listen with a microphone that captures the tiniest sounds, you would hear the rustling of pages, the shifting of weight, the beating of hearts. The silence is full of life. The quantum vacuum is the same. In every cubic centimeter of space, billions of pairs of particles, matter and antimatter, are constantly flashing into existence, living for a fraction of a nanosecond, and then annihilating each other, returning their energy to the field. This is the quantum foam. And it is happening right now, in the space in front of your nose, in the space between your eyes. Time, in this context, is the currency that allows this borrowing to happen. The universe allows reality to bend the rules of conservation of energy, but only for a fleeting moment. Time acts as a strict accountant. It demands that the debt be paid and the ledger balanced almost instantly. This constant bubbling of the field suggests that time is not just a passive stage. It is an active participant in the creation and destruction of reality. The fields are vibrating, and time is the measure of that vibration. In fact, in quantum field theory, a particle is often defined by its frequency, how fast it vibrates in time. A massive particle like an electron vibrates incredibly fast. A lighter particle vibrates slower. Time is woven into the very definition of what it means to exist. If the vibration stopped, the particle would cease to be. Let us pause here and feel the weight of this. The solidity of the world is an illusion created by the speed of these vibrations. When you touch a table, you feel resistance not because the table is a solid block of matter, but because the electron fields in your hand are interacting with the electron fields in the table. It is force against force, field against field, vibration against vibration. You are a ghost touching a ghost, and the sensation of touch is just the electromagnetic repulsion between your fields. The now that you experience is the collective crash of these waves. But there is an even deeper mystery here. If particles are just transient ripples, and if the vacuum is full of temporary ghosts, is time itself continuous? Or is it grainy? When you pour water from a pitcher, it looks like a smooth, continuous stream. But if you look with a microscope, you see individual water molecules. Is time like the water? If we could zoom in far enough, past the atoms, past the nucleus, down to the Planck scale, a length so small that it makes an atom look like a galaxy, would we see that time comes in little chunks, discrete ticks of a cosmic clock? We do not know. This is one of the greatest unsolved mysteries in physics. Our theories of gravity, general relativity, assume time is smooth. Our theories of the quantum world work well with smooth time, but they hint at a breakdown at these tiny scales. Some physicists believe that at the bottom of it all, space-time might be made of discrete atoms of space-time, tiny grains of geometry. If this is true, then time does not flow, it ticks. The universe would be like a movie reel, flashing one frame at a time, but so fast, 10 to the power of 43 frames per second, that we perceive it as a smooth motion. In this view, between the ticks of the clock, there is no time. There is no existence. We would be jumping from moment to moment across a void of non-being. This idea, known as loop quantum gravity, or causal dynamical triangulations, tries to build the fabric of space-time out of tiny, discrete blocks. It paints a picture of a universe that is pixelated at the smallest scale. But for now, let us return to the ocean, the fields. This metaphor of the fluid universe is one of the most soothing and yet most radical ideas in science. It tells us that we are not isolated beings. We are not separate from the cosmos. We are excitations of the cosmos. When you are born, the fields ripple and knot together to form the pattern that is you. You move through the universe, carrying this pattern with you, exchanging energy and information with the fields around you. And when you die, the pattern unravels. The energy is not lost. It returns to the fields. The electron that was in your heart might become part of a flower or a cloud or a beam of light traveling to a distant galaxy. The stuff of you is eternal, ancient, recycled from the beginning of time. It is a gentle thought, is it not, to know that you are made of the same fabric as the stars, that the buzzing of the fields in your mind is the same as the buzzing in the vacuum of deep space. We are the universe waking up and feeling its own vibrations. We are the ocean waving at itself. As we drift deeper into this quantum dream, we must address the arrow of time again. We established in the previous chapter that entropy gives time its direction. But in the quantum world of fields, the equations are still symmetric. An electron ripple moving forward in time looks mathematically identical to a positron, an antimatter electron, moving backward in time. In fact, Richard Feynman, another titan of physics, proposed that antimatter is simply ordinary matter traveling backward in time. Imagine that. Every time we see a particle of antimatter in a particle accelerator, we might be seeing a regular particle that has decided to turn around in the river of time and swim upstream. This suggests that, on the microscopic level, the distinction between past and future is blurred, perhaps even non-existent. The fields vibrate and the waves spread out, but the fundamental interactions can happen in either direction. So, how does the solid, irreversible arrow of time emerge from this reversible, jittery ocean? How does the quantum weirdness settle down into the predictable, flowing timeline of our lives? This is the problem of emergence. It is like asking how the wetness of water emerges from hydrogen and oxygen atoms, which are not themselves wet. Time, as we know it, might be a collective property, something that only exists when you have enough particles interacting together. Perhaps a single particle does not experience time. A photon, the particle of light, certainly does not. According to relativity, time stops completely at the speed of light. For a photon emitted by a star in the Andromeda galaxy, the journey to your eye takes 2.5 million years from our perspective. But for the photon, the moment it leaves the star and the moment it hits your retina are the same instant. Across the vast cold distances of intergalactic space, the photon experiences zero time. It is born and dies in the same breath. In a universe filled with light, filled with fields, there is a layer of reality that is timeless, stitching the cosmos together in an instant. We are creatures of mass, however. We are heavy. We drag through the Higgs field, which gives us our mass, and this drag slows us down, preventing us from moving at the speed of light. Because we cannot move at light speed, we are forced to experience time. We are forced to wait. We are forced to age. It is the price we pay for having substance. The very thing that gives us our physical form, our mass, is what traps us in the river of time. If we could shed our mass, if we could become pure energy, we would step outside of time and exist in the eternal now of the photon. So, lie back and feel the heaviness of your body. Feel gravity pulling you into your bed. That heaviness is your anchor to time. It is what keeps you here in this moment, experiencing the story of your life. It is not a burden. It is a gift. Without it, everything would happen at once. There would be no music, for music requires time. There would be no growth, for growth requires time. There would be no memory. The fields give us mass, and mass gives us time, and time gives us life. In the next chapter, we will venture even further. We will ask what happens when these fields interact with the force of gravity. We will approach the edge of the black hole, the place where time warps and twists so violently that it might stop altogether. We have explored the microscopic ocean. Soon we will explore the deep gravitational wells where the fabric of the universe is torn. But for now, simply exist. Listen to the silence, which we now know is not silence at all, but the humming of the quantum vacuum. You are a complex, beautiful, temporary song sung by the fields of the universe. And the song continues. We have floated in the vibrating ocean of quantum fields, and we have questioned the illusion of the flowing river. Now, I want you to feel the weight of your own body again. Feel the pressure of your back against the mattress or the chair. That sensation, that heaviness that anchors you to the earth, is not just a force pulling you down. It is a force pulling you through time. In our daily lives, we think of gravity as a simple attraction. The earth pulls the apple. The sun pulls the earth. But in the deep, quiet language of the universe, gravity is something far more profound. It is the curvature of the four-dimensional fabric we call spacetime. And this curvature dictates how fast your personal clock ticks compared to the rest of the cosmos. To understand this, we must return to Albert Einstein, who gave us the most beautiful theory in the history of science, general relativity. Before Einstein, we thought space was a static stage and time was a separate universal clock. But Einstein showed us that space and time are woven together into a single, flexible fabric. Imagine a trampoline. If you place a heavy bowling ball in the center, the fabric curves downward. If you roll a marble across the trampoline, it will curve around the bowling ball, not because the ball is pulling it with invisible strings, but because the surface itself is curved. This is how gravity works. Massive objects, planets, stars, galaxies, bend the geometry of the universe. But they do not just bend space, they bend time. This is not a metaphor. It is a measurable physical reality. The stronger the gravity, the slower time moves. This phenomenon is called gravitational time dilation. Right now, as you sit on the surface of the Earth, you are deep within a gravity well. Your feet are slightly closer to the center of the Earth than your head. Because gravity is stronger at your feet, time actually passes more slowly for your feet than it does for your head. The difference is infinitesimally small, a fraction of a nanosecond over a lifetime, but it is real. If you were to live your entire life at sea level, you would age slightly less than your twin who lived on top of Mount Everest. The mountain climber, being farther from the Earth's mass, experiences time flowing just a tiny bit faster. We see this confirmed every single day by the technology in our pockets. The Global Positioning System, or GPS, relies on a network of satellites orbiting about 12,000 miles above the Earth. These satellites are moving fast, which slows their time down according to special relativity. But they are also far away from Earth's gravity, which speeds their time up according to general relativity. The gravitational effect is stronger. The clocks on these satellites tick faster than the clocks on the ground by about 38 microseconds per day. That might sound like nothing, a fleeting moment in the vastness of a day. But light travels fast. In 38 microseconds, light travels about 7 miles. If the engineers who designed the GPS did not program the satellites to account for this warping of time, if they did not accept that time is malleable, the navigation system in your car would drift by 7 miles every single day. Within a week, you would be lost. The fact that you can find your way to the grocery store is proof that gravity warps time. Now, let us take this concept to its extreme. Let us leave the gentle gravity of Earth and travel to the center of our galaxy, the Milky Way. There, shrouded in dust and gas, lies a monster. It is a supermassive black hole known as Sagittarius A star. It contains the mass of 4 million suns crushed into a region smaller than our solar system. The gravity here is so intense that space falls inward faster than the speed of light. And time is stretched to its breaking point. Imagine you are an astronaut on a journey to this black hole. You decide to get close, dangerously close, while I stay safely far away in a distant spaceship, watching you through a telescope. As you approach the black hole, you would see the stars behind it warped into a ring of light, a cosmic lens bending the image of the universe. You would feel the tidal forces, the difference in gravity between your head and your feet, threatening to stretch you. But let us focus on your clock. From my perspective, watching you fall, something strange begins to happen. As you get closer to the event horizon, the point of no return, I see your movements slow down. Your wave to me becomes a slow-motion gesture that takes hours, then days, then years. The light coming from your ship turns redder and redder, shifting into infrared, then radio waves, as it struggles to climb out of the deep gravitational well, losing energy and stretching out its frequency. From my perspective, you never actually cross the event horizon. You simply fade away, frozen in time, a ghostly image hovering on the edge of forever. To the outside universe, You have become a permanent fixture of the black hole's surface, plastered onto the horizon like a fly on flypaper, but your experience is radically different. From your perspective, you do not slow down. You do not freeze. You check your watch, and it is ticking normally. Thump, 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 thump. You cross the event horizon without a bump, without a flash of light. You pass the point of no return, and the universe behind you begins to close up like an aperture. But once you are inside, the rules of reality invert. This is one of the most terrifying and beautiful concepts in physics. Inside a black hole, space and time swap roles. In the outside world, you can move freely through space, left, right, up, down. But you are forced to move forward through time. You have no choice but to go to tomorrow. Inside the event horizon, the radial direction, the path toward the singularity at the center, becomes your time. The singularity is no longer a place in space. It is a moment in your future. Just as you cannot stop next Tuesday from arriving, you cannot stop yourself from hitting the singularity. You are falling toward the end of time itself. What happens at the singularity? Our equations tell us that the curvature of space-time becomes infinite. The density becomes infinite. The laws of physics as we know them break down. We call this a singularity, not because we know what it is, but because it is the point where our math fails. It is a tear in the fabric of the block universe. And here lies the great conflict, the silent war at the heart of modern physics. We have general relativity, which describes this smooth, heavy, curving space-time. And we have quantum field theory, which describes the jittery, granular ocean of particles. When we try to use quantum mechanics to describe the center of a black hole, the theories refuse to talk to each other. They yield nonsense. Infinity minus infinity. This conflict is the crisis of physics. It suggests that our understanding of time is fundamentally broken. General relativity assumes time is a smooth, continuous coordinate. Quantum mechanics assumes time is a background parameter for vibrations. But if gravity is the curvature of space-time, and if the quantum world is made of discrete particles, does that mean space-time itself is made of particles? Is there a graviton, a particle of gravity, that carries the force? If so, is time just the result of trillions of gravitons interacting? Like a sandy beach looks smooth from a distance, but is made of grains when you are close. Some physicists believe that at the bottom of the black hole, time dissolves completely. There is no when. There is only a pure, timeless geometry, a state of being that exists outside of our comprehension. This brings us back to the idea of the hologram. The holographic principle suggests that all the information about what falls into a black hole is not lost, but is encoded on the surface, on the event horizon itself. Imagine a soup can. The soup is the three-dimensional reality inside, but the label on the outside describes everything that is in the soup. The universe might be like that label. The three-dimensional world we experience, the depth, the distance, the feeling of moving through a room, might be a projection from a two-dimensional surface at the edge of the cosmos. If this is true, then time is just part of the projection. It is a hologram. Let that thought wash over you. The vastness of the cosmos, the depth of the night sky, the feeling of distance between you and the stars. It might all be a magnificent illusion generated by a distant, flat reality. And if time is a projection, then the history of the universe is just the information encoded on the boundary. We are the shadows on the wall of Plato's cave, dancing to a light we cannot see. But let us return to the feeling of weight. Gravity. It is the only force that travels across all dimensions. It is the only force that cannot be shielded. You can block light. You can block magnetic fields, but you cannot block gravity. It reaches out from the beginning of the universe to the end. It connects every atom to every other atom. The gravity of a star in the Andromeda galaxy is tugging on you right now. It is a tiny, imperceptible tug, but it is there. You are connected to the entire web of the cosmos by this heavy, silent curve. And think about the Earth's core. In the 1960s, the brilliant physicist Richard Feynman made a rough calculation. He estimated that because the center of the Earth is under more gravity than the surface, the core should be younger than the crust. Years later, scientists did the calculation with more precision and confirmed it. The center of our planet is approximately 2.5 years younger than the surface. Because of the time dilation caused by the Earth's own mass, the core has traveled through less time than the mountains. The ground beneath your feet holds a different time than the sky above your head. We are walking on a planet that is not chronologically uniform. It is a layered cake of different times, all moving together through the void. This relativity of time can be isolating. It means that your now is unique to you. No one else in the universe shares your exact slice of the moment. We are all trapped in our own private bubbles of time, syncing up only when we are close, only when we touch. But it is also connecting. It means that we are not static objects in a static box. We are dynamic travelers. We are surfing the waves of geometry. Every time you stand up, you change the rate at which you age. Every time you move, you rotate your perspective in the four-dimensional block. You are an active participant in the structure of reality. In the silence of your room, consider the journey of the light that is allowing you to read this, or the sound waves carrying my voice. They are traveling through a medium that is curved by the earth, curved by the sun, curved by the Milky Way. The path is not straight. Nothing in the universe is straight. Everything is falling. The moon is falling around the earth is falling around the sun is falling around the black hole, and we are falling with them, caught in a graceful, eternal freefall that we call an orbit. To exist is to fall. To experience time is to surrender to the curve. As we prepare to leave the heavy, warping world of gravity, we must ask, if time can bend, can it break? If it can slow down, can it stop? And most importantly, if the quantum fields from our previous chapter are the fundamental reality, how do they create this heavy, curved space-time? Is gravity actually just a side effect of quantum entanglement? This is one of the newest and most exciting ideas in physics, that space-time is stitched together by spooky action at a distance. That the reason you are close to your chair is because the particles in your body are entangled with the particles in the chair. In the next chapter, we will dissolve the solid world once again and look at the concept of emergence. We will ask if time is like heat, a property that only exists when you have lots of pieces moving together. Does a single atom have a temperature? No. Does a single atom have time? Perhaps not. We will explore the idea that time is a thermodynamic mist, a statistical accident that allows us to exist. But for now, stay with the gravity, feel the gentle pull of the planet. It is the Earth hugging you, holding you close, slowing down your time ever so slightly to keep you here a little longer. It is a cosmic embrace. You are heavy because you matter. You warp the universe just by being in it. The fabric of space-time bends around you, acknowledging your presence. You are not just in the universe, you are of it, and you are shaping it with every beat of your heart. Let the heavy curve of the night cradle you. There is no rush. The black hole at the center of the galaxy is far away, and even there, time does not end. It transforms. We are safe here, in the gentle gravity of home, spinning slowly in the vast, quiet dark. Have you ever stared into a cup of hot tea and watched the steam rise? It curls and dances, twisting into complex shapes before vanishing into the air. If you touch the cup, you feel warmth spreading into your fingertips. It feels like a physical substance, this heat flowing from the tea into you. For centuries, scientists believed that heat was exactly that, an invisible fluid called caloric that poured from hot objects to cold ones. It made perfect sense. It fit our intuition, but we were wrong. We discovered that heat is not a fluid. It is not a thing. It is a behavior. Heat is simply the frantic motion of trillions of atoms bouncing off each other. When you burn your hand, it is not because a substance entered your skin. It is because the atoms of the stove were vibrating violently and transferred that violence to the atoms of your hand. Heat is an emergent property. It only exists when you zoom out. A single atom is not hot. A single atom is not cold. It just has speed. Temperature is a statistical average, a ghost that rises from the chaos of the many. Now, let us ask the most dangerous question in physics. Is time like heat? Is the flowing river we feel just a statistical mist? Is the past and the future just a symptom of our inability to see the details? This is the hypothesis of emergent time, and it suggests that at the deepest level of reality, time does not exist. It is a ghost, a shadow cast by the sheer complexity of the universe. To understand this, we must visit the tragic and brilliant figure of Ludwig Boltzmann, a man who saw the atomic world before anyone else believed it was real. Boltzmann realized that the arrow of time, the reason eggs break but never unbreak, is a matter of probability, not certainty. Imagine you have a box of puzzle pieces. If you shake the box, what are the odds that the pieces will accidentally fall into a perfect picture of a landscape? Practically zero. There is only one way for the puzzle to be solved, but there are trillions upon trillions of ways for it to be disordered. The solved state is a state of low entropy. The jumbled state is a state of high entropy. The universe moves toward high entropy simply because there are more ways to be messy than to be tidy. This is the second law of thermodynamics. But here is the catch. It is not a law of physics like gravity or electromagnetism. It is a law of large numbers. It is a statistical likelihood. If you wait long enough, an unimaginable span of time, far longer than the current age of the universe, it is theoretically possible for the puzzle pieces to shake themselves into a perfect picture. It is possible for the milk to separate from the coffee. It is possible for the egg to unshatter. It is just incredibly, vanishingly unlikely. This means that the flow of time is not a fundamental rule. It is a statistical accident. We perceive a past and a future only because we are riding a wave of probability from an unlikely state to a likely one. We are surfing the gradient of chaos. But the idea of emergent time goes even deeper than entropy. It suggests that time itself is a measure of our ignorance. This concept, sometimes called the thermal time hypothesis, was championed by modern physicists like Carlo Rovelli. Imagine you're looking at a crowd of people from a helicopter. You see a blob moving through the streets. You can describe the speed and direction of the crowd. but you do not see the individual people. You do not see their eye color, their shoelaces, or the thoughts in their heads. You have coarse-grained the information. You have blurred the details to see the big picture. In physics, we describe the state of a system like a box of gas by its macroscopic properties: pressure, temperature, volume. We do not track the position and velocity of every single one of the trillion atoms inside. That would be impossible. We ignore the microscopic details. This act of ignoring, of blurring, is what creates the variable we call time. If we could know the exact position and momentum of every particle in the universe, if we had what is called perfect information, time might disappear. In a world of perfect knowledge, there is no entropy increasing because every state is unique and precisely defined. There is no flow from order to disorder. There is just the eternal shifting geometry of the state space. This is a profound and unsettling thought. It implies that time is a perspective. It is an artifact of our limitations. We are finite beings with finite brains. We cannot process the infinite complexity of the quantum fields. So our brains average things out. We blur the quantum foam into smooth space. We blur the frantic vibrations of atoms into temperature. And we blur the sequence of causal events into time. We create the river because we cannot see the water molecules. If this hypothesis is true, then the universe is not actually happening. It simply is. The happening is our way of reading the book. We are crawling through the static block of space-time, using our limited senses to build a coherent story, like a flashlight beam moving across a dark painting. The painting does not change. The beam moves. But what moves the beam? That is the mystery of consciousness, the hard problem that sits at the intersection of physics and philosophy. Why do we feel like we are the flashlight? Let us return to the puzzle pieces. The fact that we see a past means that the universe started in a state of incredibly low entropy. This is called the past hypothesis. For reasons we do not understand, at the moment of the Big Bang, the universe was exquisitely ordered. It was a tightly wound spring, ready to uncoil. For 14 billion years, we have been living off the energy of that initial winding. Every time you eat an apple, you are consuming the order that was packed into the universe at the beginning of time. Every time you think a thought, you are burning that ancient fuel, creating a little bit of heat, a little bit of disorder, paying the price for your existence. We are creatures of the mist. We live in the gradient. If the universe reaches thermal equilibrium, the state of maximum entropy, where everything is evenly spread out and the temperature is the same everywhere, time will stop. Not because the clocks break, but because nothing will happen. There will be no flow of energy, no distinction between one moment and the next. This is the heat death of the universe. In such a world, without the flow of heat, there can be no thought, no memory, no life. Time requires imbalance. It requires a difference between here and there, between hot and cold, between order and chaos. So, when you feel the warmth of the sun on your face, you are feeling the flow of time. You are feeling the universe trying to balance itself. You are standing in a stream of entropy that began with the Big Bang and will end in the eternal dark. It is a melancholy thought, perhaps, but also a beautiful one. It means that our lives are rare, precious fluctuations. We are intricate knots of order in a universe that wants to be smooth. We are resisting the drift, if only for a few decades. But what gives rise to this order? If time is just a statistical fog, What lies beneath the fog? What is the solid ground? Some theories suggest that the fundamental reality is not space or time, but information, quantum information. In this view, the universe is not made of matter. It is made of bits, like a cosmic computer. The it-from-bit hypothesis, proposed by John Archibald Wheeler, suggests that every particle, every field, every force is ultimately the answer to a yes or no question posed by the universe. Time, then, would be the processing speed of this cosmic computation. It would be the rate at which the universe processes information, changing from one state of bits to another. And here, in the realm of information, we find the ghost again. If information is conserved, if quantum mechanics is correct, and information is never destroyed, then the past is never erased. It is just scrambled. Imagine burning a book. The pages turn to ash. The ink turns to smoke. To us, the book is gone. The information is lost. But to the universe, the information is still there. It is hidden in the positions of the smoke particles, in the heat of the ash, in the light of the flame. If you could capture every single photon and every single molecule of smoke, and if you had a powerful enough computer, you could theoretically reverse the process and reconstruct the book. The story is not destroyed. It is just hidden in the chaos. This means that forgetting is also a thermodynamic illusion. The universe remembers everything. Every word you have spoken, every dream you have had, every tear you have shed, the information that describes those events is woven into the quantum state of the cosmos forever. It might be inaccessible to us, scattered into the thermal mist, but it is not gone. We are written into the fabric of reality with indelible ink. As we lie here, contemplating the emergent nature of our lives, consider the air in your room. Trillions of molecules are hitting your skin every second. You do not feel the individual hits. You feel a constant pressure. You do not feel the individual chaotic motions. You feel a steady temperature. You are experiencing the average. You are experiencing the macro state. In the same way, you do not feel the quantum ticks of the universe. You feel the smooth flow of time. We are shielded from the jagged, chaotic truth by the law of large numbers. We are protected by the blur. But what happens when the blur clears? What happens when we look at the connections between things that are not supposed to be connected? In the next chapter, we will explore the phenomenon that Einstein called spooky action at a distance. We will look at quantum entanglement. We will ask if the reason space and time hold together is because everything is secretly touching everything else. We will explore the idea that space is not a stage, but a network of connections, a web of quantum threads stitching the universe into a coherent whole. For now, embrace the mist. Embrace the fact that you are a statistical miracle. In a universe that tends toward chaos, you are a marvel of order. You are a temporary island of complexity in a sea of entropy. And even if time is just a shadow, the shadow is real to us. The warmth of the tea is real to the hand. The love we feel is real to the heart. The illusion is the only reality we have, and it is a beautiful place to live. Let yourself drift in the statistical fog. The atoms in your body are borrowing energy, vibrating, interacting, creating the sensation of you and the sensation of now, out of the timeless quantum void. You are a ghost made of stardust, haunting the probability waves of the cosmos. And as long as the universe is out of balance, as long as the heat flows and the stars shine, you have a story. Deep in the equations of thermodynamics, there is a variable called Koch, Boltzmann's constant. It relates the microscopic world of atoms to the macroscopic world of temperature. It is the bridge between the invisible and the visible. Think of your consciousness as that bridge. You are the observer standing on the arch, looking down at the river of time, knowing it is made of droplets, but enjoying the flow nonetheless. The mystery of emergence is the mystery of how mind rises from matter, how time rises from timelessness. It is the magic trick of the cosmos, performed so perfectly that we forget it is a trick. Rest in the certainty that you are part of the great unwinding. The spring of the universe is loosening, and your life is one of the gears turning in the vast, silent clockwork. It is a quiet, steady movement, carrying us all toward the same destination, through the same beautiful, emergent mist. Have you ever felt a sudden, inexplicable connection to someone far away? A moment where you thought of a friend just seconds before they called, or felt a pang of worry for a loved one across the ocean, only to find out later they were in distress. We often dismiss these moments as coincidence, tricks of the mind, or wishful thinking. In the cold, hard world of classical physics, objects are separate. You are there, and I am here. The space between us is a vast, empty gulf that can only be crossed by sending a signal, a sound wave, a beam of light, a radio message. And since nothing can travel faster than the speed of light, there is always a delay. There is always a lag. We are locked in our own local bubbles of reality, isolated by the tyranny of distance. If the sun were to disappear right now, the Earth would continue to orbit a ghost for 8 minutes. Gravity, light, information, they all obey the speed limit. This separation feels absolute. It feels fundamental to the human condition. We are islands in the dark. But what if I told you that this isolation is the greatest illusion of all? What if, beneath the surface of the visible world, in the deep quantum basement of reality, there is no such thing as distance? What if space is not an empty stage that separates things, but a physical network that connects them? We are about to explore the most mind-bending phenomenon in all of physics, a concept so strange that it kept Albert Einstein awake at night and drove him to question the very foundations of quantum mechanics. We are going to talk about quantum entanglement, or as Einstein famously called it, spooky action at a distance. And in doing so, we might just find the secret architecture that holds the universe, and perhaps even time itself, together. Before we dive into this spooky action, I want to take a moment to thank you for walking this path with me. I am Walter, the Explorer, and it is a privilege to be your guide through these cosmic mysteries. I have noticed that about 73% of the wonderful people listening to these stories have not yet subscribed to the channel. If these nightly journeys bring you a sense of peace or wonder, and if you want to support our mission to explore the universe together, please consider subscribing. It helps us immensely to keep creating this content for you. Now, let us return to the invisible threads that bind the cosmos. Imagine you have 2 coins. You give one to a friend who travels to Mars, and you keep one here on Earth. If you flip your coin and it lands on heads, that tells you absolutely nothing about what your friend's coin will do. They are separate objects with separate histories. The result of your flip is random, and the result of their flip is random. This is how the classical world works. Things have their own private properties. But in the quantum world, particles like electrons or photons can become entangled. This happens when they interact in a certain way. Perhaps they are created together in a laser beam or collide in a particle accelerator. When they become entangled, They lose their individual identities. They are no longer two separate particles. They are a single mathematical object that just happens to be in two places at once. If you take two entangled electrons, they have a property called spin. You can think of spin as the direction the particle is rotating, although it is a bit more abstract than that. Let us say the total spin of the pair must be zero. If one is spinning up, the other must be spinning down to cancel it out. Now, imagine we separate these entangled electrons. We keep one in a lab in New York and send the other to a lab in a galaxy 10 billion light years away. According to quantum mechanics, until you measure them, neither electron has a definite spin. They are both in a superposition of up and down simultaneously. They are undefined. But the moment you measure the electron in New York and find it is up, the electron in the distant galaxy instantaneously, with zero time delay, becomes down. It is as if the universe flips a single coin that spans billions of light years. The particle in New York knows what happened to its partner across the universe faster than a beam of light could ever travel between them. Einstein hated this idea. He believed that nothing could travel faster than light, not even information. He argued that the particles must have had a secret plan all along, a hidden list of instructions that told them what to do, like a pair of gloves in boxes. If you open a box and find a left glove, you know the other box has a right glove, not because of magic, but because they were always left and right. But Einstein was wrong. Decades of experiments, starting with the brilliant physicist John Bell, proved that there are no hidden instructions. The particles are truly undecided until the moment of measurement. The universe really is non-local. What happens here has an immediate, ghostly effect on what happens there, regardless of the distance. This shatters our intuition about space. It suggests that distance is not a barrier to connection. In the quantum realm, here and there are not absolute concepts. Two particles can be separated by the entire observable universe, and yet be as intimately connected as if they were touching. They are threads in the same tapestry, vibrating in unison. And this leads to a radical new idea that is currently setting the world of theoretical physics on fire. The idea that space itself is built out of these connections. Think about a sweater. It looks like a continuous piece of fabric, soft and smooth. But if you look closely, it is made of thousands of individual knots and threads. If you pull a thread, the whole sweater can unravel. Some physicists, like Juan Maldacena and Leonard Susskind, have proposed a theory known as ER equals EPR. This sounds like a complex equation, but the idea is beautifully simple. ER stands for Einstein-Rosen bridge, which is the technical name for a wormhole, a tunnel through spacetime that connects two distant points. EPR stands for Einstein-Podolsky-Rosen, which refers to quantum entanglement. The conjecture is that these two things, wormholes and entanglement, are actually the same thing. When two particles are entangled, they are connected by a tiny, microscopic wormhole, a thread of space-time geometry stitching them together. If this is true, then space is not an empty box that particles sit in. Space is the result of trillions upon trillions of particles being entangled with each other. The reason you cannot walk through a wall is that the particles in your body are not entangled with the particles in the wall in the right way to form a bridge. The reason space feels continuous and solid is that the web of entanglement is so dense, so tightly woven, that we perceive it as a smooth fabric. We are walking on a quilt of quantum threads. This changes the meaning of separation. If space is stitched together by entanglement, then separation is just a lack of entanglement. To be distant is simply to be less connected. But here is the most profound part. Everything in the universe was once crushed together in a single point at the Big Bang. In that primordial fireball, 14 billion years ago, every particle interacted with every other particle. Matter was so dense that everything was touching. This means that, in a deep sense, the entire universe is entangled. The electrons in your heart are entangled with the electrons in the center of the sun, and with the electrons in the farthest quasar. The threads have stretched, and the web has grown vast. But the connection has never truly been broken. We are not isolated fragments. We are parts of a single, breathing whole. The separation we feel, the loneliness of being a single consciousness in a vast cosmos, is a surface-level illusion. Deep down, where the roots of reality drink from the quantum ocean, we are all one thing. We are the universe observing itself from billions of different perspectives, but the underlying unity remains. When you look up at the stars, you are not looking at alien worlds. You are looking at distant parts of yourself. The light that hits your eye is a handshake between two parts of the same cosmic body. Now, let us bring this back to time. If space is created by entanglement, what about time? In the previous chapters, we asked if time flows or if it is a block, but entanglement suggests something even stranger. If instantaneous connection is possible, does now even exist? If a measurement here creates a reality there instantly, it slices through the block universe at a weird angle. It implies that the universe has a holistic now that we cannot perceive, a state of global existence that transcends the speed of light. Some theories suggest that time itself emerges from the entanglement of the universe. As particles become more entangled, as the web grows more complex, the clock of the universe ticks forward. The arrow of time, the increase of entropy, might just be the increase of entanglement. As things interact, they get more mixed up, more connected, more inseparable. The past is a state of low entanglement. The future is a state of high entanglement. We are moving toward a state of total connection. Think about the implications for your own life. We often feel that our actions are small, that they disappear into the void without a trace. But in an entangled universe, nothing is ever isolated. Every thought, every movement, every breath changes the quantum state of the world. You are constantly entangling yourself with your environment. You leave a trail of quantum connections wherever you go. The air you breathe out is entangled with your lungs. The chair you sit on is entangled with your body. The light you reflect is entangled with your skin. You are knitting yourself into the universe with every passing second. You are not a passenger. You are a weaver. And what about the people we love? If entanglement is the physical bond that holds space together, is love the emotional bond that mirrors it? When we feel close to someone, when we feel that we can sense their moods or their pain across a distance, are we sensing a macroscopic echo of this quantum truth? Science cannot yet say that telepathy is real or that love is a quantum force, but the metaphor is powerful. We are drawn to connection because we are made of connection. We seek unity because unity is our fundamental state. The pain of loneliness is the pain of fighting against the structure of reality. To be alone is unnatural in a universe built on threads. Let us go deeper into the ER equals EPR idea. Imagine a black hole. We talked about them as monsters of gravity. But in this new view, a black hole is a tangle of intense entanglement. It is a knot in the web. If you had two entangled black holes, you would have a wormhole big enough to travel through. You could jump into one black hole and emerge from the other, traversing a shortcut through the geometry of space-time. This sounds like science fiction, but it is serious mathematics. It suggests that the inside of a black hole is not a dead end, but a bridge. And if space is made of these bridges, then the universe is a labyrinth of tunnels, a hall of mirrors where every path leads back to the center. In the silence of your room, try to visualize these invisible threads. Imagine them glowing with a soft blue light. See them extending from your chest, from your hands, reaching out through the walls, through the roof, rising into the sky. See them connecting you to the trees outside, to the sleeping birds, to the clouds drifting overhead. Follow them further, out past the atmosphere, to the moon, to the planets, to the stars. The universe is not a dark, empty void. It is a luminous web, pulsing with information, alive with silent communication. You are a node in this web. You are a point of convergence where billions of threads meet. This perspective dissolves the fear of the dark. The dark is not empty. It is full. It is full of the potential for connection. It is full of the spooky action that Einstein feared, but which we can now embrace as the glue of existence. It means that the universe is intimately aware of itself. It is not a blind, dumb machine. It is a sensitive instrument. A pluck on a string here vibrates a string there. A star collapsing in a distant galaxy sends a shiver through the gravitational field that passes through your body. We are touching the stars, and the stars are touching us in every moment of every day. The concept of non-locality is difficult for our primate brains to grasp. We evolved to understand rocks and sticks, things we can reach with our arms. We evolved to understand near and far, but our minds are capable of transcending our evolution. We can close our eyes and model a universe where far is just a word, where the separation between subject and object, observer and observed, melts away. In the quantum world, the observer is part of the system. You cannot look at the universe from the outside because there is no outside. You are inside the experiment. You are the experiment. As we rest here, suspended in the web of space-time, we can find a deep comfort in this lack of separation. It means that loss is in a way impossible. If everything is entangled, then nothing truly leaves. The pattern might change, the form might dissolve, but the connection remains written in the quantum ledger. The information that makes up you and the information that makes up the people you have lost is still there, woven into the same fabric. We are all swimming in the same ocean of fields, held together by the same invisible hands. In the next chapter, we will turn our gaze inward. We have looked at the particles, the fields, the gravity, and the entanglement. But who is doing the looking? We will approach the measurement problem. We will ask why the quantum world of possibilities collapses into a single, sharp reality when we look at it. Does consciousness create time? Does the act of witnessing the universe force it to choose a path? We will explore the role of the mind in the construction of the cosmos. But for now, stay with the threads. Feel the invisible embrace of the universe. You are held. You are supported. You are connected to the bedrock of reality by bonds that can never be broken. The spooky action is not scary. It is a promise that you belong, a promise that you are home everywhere you go. Let the silence deepen around you, knowing it is a silence full of whispers. The atoms of the air are dancing with the atoms of your skin. The gravity of the earth is dancing with the gravity of your body. The light of the ancient past is dancing with the retina of your eye. It is all one dance, one vast entangled shimmering motion, and you are the music as much as you are the dancer. Sleep in the knowledge of this unity. Let the illusion of isolation fade like mist. The universe is holding your hand, even in the dark. Does the moon exist when you are not looking at it? This sounds like a question a child might ask, or perhaps a riddle posed by a philosopher sitting under a tree thousands of years ago. But in the 20th century, this precise question kept Albert Einstein awake at night. He was walking in the garden of Princeton University with the physicist Abraham Pius, and he stopped, turned to his friend, and asked with genuine concern, "Do you really believe the moon is not there when you are not looking at it?" Einstein wanted the answer to be yes. He wanted a universe that was solid, objective, and independent of our minds. He wanted a world where the stars burned and the planets spun, regardless of whether any eyes were there to witness them. But the quantum theory that Einstein helped create was whispering a different, more unsettling story. It was suggesting that the act of looking is not passive. It is an act of creation. It suggests that until a measurement is made, reality is not a thing, but a haze of possibilities, a ghost world where everything that can happen is happening simultaneously. Imagine you are reading a book. In the classical world, the words are printed on the page in ink. They are there whether the book is open or closed. But in the quantum world, the book is different. When the cover is closed, the pages are blank. Or rather, they are not blank. They are filled with every possible story at once. The letters are dancing, rearranging themselves, flowing like liquid. It is only when you open the cover, when you perform the act of measurement, that the letters freeze into a specific sentence. You, the reader, force the story to choose a path. This is the measurement problem, and it stands as the tallest, most formidable gatekeeper between us and the true nature of time. If time is the page we are reading, do we write the page just by looking at it? Does the universe wait for us to wake up before it decides what to do? I am Walter, the explorer, and I am grateful that you have chosen to open this book with me tonight. I have noticed that about 73% of the curious minds traveling with us on this journey have not yet subscribed to the channel. If these stories help you find a moment of stillness in a chaotic world, and if you want to ensure we can keep exploring these mysteries together, please take a moment to subscribe. It is a small action for you, but it means the world to us. It helps us keep the lantern lit. Now, let us step into the box with the cat. To understand the power of the witness, we must visit the most famous thought experiment in history, Schrödinger's cat. In 1935, Erwin Schrödinger, one of the founding fathers of quantum mechanics, devised a scenario to show just how absurd the theory had become. He imagined a steel chamber. Inside the chamber, there is a cat. Along with the cat, there is a tiny amount of radioactive material, so small that perhaps one atom decays in the course of an hour, or perhaps none. If an atom decays, a Geiger counter detects it and triggers a hammer that shatters a flask of poison, killing the cat. If the atom does not decay, the cat lives, according to the strict rules of quantum mechanics. Until you open the box to look, the atom is in a superposition. It is both decayed and not decayed. It is a wave of probability spread out over time. But because the cat's fate is tied to the atom, the cat must also be in a superposition. Until the box is opened, the cat is mathematically both dead and alive. It is a blur. It is a ghost cat suspended in a twilight state of existence. Schrodinger intended this as a joke, a reductio ad absurdum, to show that quantum mechanics could not possibly apply to everyday objects. A cat cannot be dead and alive. It is one or the other. Common sense demands it. But nature ignored Schrodinger's sarcasm. Experiment after experiment has shown that this superposition is real. We have done it with atoms, with molecules, and even with tiny vibrating drums visible to the naked eye. We have put them in two states at once. They are there and not there, moving and still. The wave function, the mathematical description of the system, denoted by the Greek letter psi, contains all these possibilities. It evolves smoothly through time, a spreading ripple of maybe. But the moment we look, the moment we measure, the wave function collapses. The ripple snaps into a point. The maybe becomes is. The cat is found alive. The story freezes. This collapse is violent. It breaks the smooth symmetry of the quantum world. It is an irreversible event. And here is where time enters the room wearing a mask. If the wave function evolves smoothly, time is symmetric. It can go forward or backward. But the collapse? The collapse only happens in one direction. You cannot unmeasure the cat. You cannot unsee the result. The act of observation creates an arrow of time. It drives a stake into the heart of the present moment, separating the fuzzy future from the concrete past. We are the needle on the record player, and our consciousness is the diamond tip that turns the silent grooves into music. But this leads to a terrifying question. What counts as a measurement? Does it require a human? Does it require a PhD in physics? Or can a camera do it? Can a fly do it? Can the air molecules in the box do it? This is where the debate fractures into different schools of thought, each one more mind-bending than the last. One interpretation, the Copenhagen interpretation, suggests that there is a fundamental split between the quantum world and the classical world. It says that we, the observers, stand outside the system. We are the gods of the experiment. When we interact with the quantum potential, we force it to become real. This places consciousness, or at least the macroscopic measuring device, at the center of creation. It echoes the ancient philosophical idea of idealism, that mind is primary and matter is secondary. In this view, the universe is a dream that solidifies only when the dreamer focuses their attention. But there is another interpretation, one that removes the special role of the observer, but adds an infinite weight to the cosmos. It was proposed by Hugh Everett III in 1957. He looked at the math and asked, what if the wave function never collapses? What if the cat does not choose? What if the atom does not decide? Everett suggested that every possible outcome of a quantum event actually happens. In one branch of reality, the atom decays and the cat dies. In another branch, the atom remains stable and the cat lives. But these two branches do not communicate. They split. The universe bifurcates. This is the many worlds interpretation. If it is true, then right now, in this room, there are infinite versions of you. There is a version of you who stopped reading this sentence. There is a version of you who fell asleep 10 minutes ago. There is a version of you who made a different choice at breakfast, a different choice at college, a different choice in love. Every time a quantum event occurs, which is trillions of times per second in every atom of your body, the universe splits into copies. We are riding a branching tree of time, a fractal cauliflower of realities, growing into an infinite dimensional space. In the many worlds view, Time is not a single line. It is a garden of forking paths. The you that you experience is just one path through the garden. The other paths are just as real, populated by other yous, who feel just as unique and singular as you do. They are your ghost siblings, separated by the wall of decoherence, never to meet. This idea is dizzying. It makes us feel incredibly small, just one facet of a diamond with infinite faces. But it also makes us feel infinite. It means that everything that can happen does happen. Somewhere, in the vast library of the multiverse, you solved the problem. Somewhere, you saved the day. Somewhere, you did not make that mistake. And what creates the illusion of a single timeline? Why do we only see one cat? This is explained by decoherence. Imagine the cat in the box again. It is not just floating in a void. It is surrounded by air. Photons of light are bouncing off its fur. The box is sitting on a table. The environment is constantly interacting with the cat. These interactions are like tiny measurements. The air molecules measure the cat's position. The light measures its state. This constant leakage of information into the environment causes the superposition to scramble. The quantum coherence leaks out into the room, then into the building, then into the atmosphere. To an observer, it looks like a collapse, but in reality, it is just entanglement spreading. You become entangled with the cat. You become part of the branch where the cat is alive. Another version of you becomes entangled with the dead cat. The universe did not choose. It just multiplied. So, what is time made of in this multiverse? Time is the branching. Time is the measure of how far apart the worlds have drifted. The past is the trunk of the tree, the shared history where all the versions of you were once the same person. The future is the canopy, the billion twigs reaching out into the unknown. We are climbing the tree, moment by moment, leaving a trail of ghost selves behind us at every fork. This perspective is haunting, but also strangely beautiful. It removes the randomness. Einstein said, God does not play dice with the universe. In many worlds he is right. There are no dice. The outcome is not random. It is total. Every face of the die comes up. The randomness is only in our perspective in asking, which branch am I on? It is a subjective illusion caused by our limited view. But let us return to the witness. Whether you believe in the collapse or the branching, the fact remains that your consciousness is the window through which the universe is seen. This brings us to a variation of the cat paradox known as Wigner's friend. Eugene Wigner, another Nobel laureate, imagined that his friend was inside the lab performing the experiment, while Wigner waited outside. To the friend, the cat collapses to alive or dead the moment the box is opened. But to Wigner, waiting in the hallway, the friend and the cat are in a superposition until Wigner opens the door to ask the result. Who collapses the wave function? The friend? Wigner? What if there is someone outside the building observing Wigner? Is there an infinite chain of observers? Does the universe require a final observer, a cosmic consciousness or a god, to look at the whole thing and make it real? These questions push physics to the breaking point. They suggest that mind and time are inextricably linked. Perhaps time is not a container for consciousness, but a creation of it. Perhaps the flow of time is just the way consciousness processes the information of the quantum field. We are weaving the raw wool of potential into the thread of history. As you lie there, feeling the quiet of the night, think about the power of your attention. You are a collapse engine. Wherever you look, the world freezes into clarity. The blurry edges of your peripheral vision, the unobserved rooms of your house, they are softer, filled with quantum noise, but your focus is a laser that cuts reality out of the fog. You are not a passive spectator. You are a participant. The universe needs you. It needs you to look at the stars so they can be bright. It needs you to listen to the silence so it can be deep. Without you, the movie plays to an empty theater, and in quantum mechanics, a movie with no audience might not be playing at all. There is a deep loneliness in the many worlds, the sorrow of the roads not taken, but there is also a deep solidarity. If all those other versions exist, then the sum of you is vast beyond comprehension. You are living every life. You are experiencing every joy and every sorrow. The you that is here, resting, listening to this story, is just the tip of the iceberg, the focal point of a multidimensional being that spans the probability space of the cosmos. And consider memory. If the past is just a branch we have left behind, why do we remember it? Memory is the trace of the path we took. It is the breadcrumbs we dropped as we climbed the tree. But sometimes memories feel unreliable. Sometimes they shift. Is it possible that in a quantum universe, the past is not as fixed as we think? If the future is a wave of probability, perhaps the past is also a wave, only slightly more crystallized. As we look back, we might be collapsing the past just as we collapse the future. We tell ourselves stories about who we were, and those stories become the reality of the branch we are on. We are writing our history and our destiny simultaneously. In the next chapter, we will leave the paradoxes of the observer and travel back to the ultimate source of the arrow of time. We will go to the beginning, to the Big Bang. We will ask, why did the universe start in such a low entropy state? Why was the spring wound so tight? We will explore the past hypothesis and the birth of order from chaos. We will see how the Big Bang was not just an explosion of matter, but an explosion of time itself. But for now, be the witness. Close your eyes and watch your thoughts. Watch them rise from the quantum foam of your mind and dissolve back into silence. You are the observer behind the thoughts. You are the silent presence that makes the world real. The moon is there because you are there. The night is there because you are there. You are the anchor. Sleep well, conscious traveler. The universe is safe in your gaze. Have you ever dropped a glass on the kitchen floor? It is a startling sound, a sharp crack that shatters the silence of the morning. You watch as the shards skitter across the tiles, coming to rest in a chaotic pattern of glimmering debris. In that moment, you are witnessing one of the most fundamental laws of the universe. The glass breaks, it never unbreaks. You never see the shards leap up from the floor, knit themselves back together, and land perfectly in your hand as a pristine vessel. The milk you spill never gathers itself back into the carton. The smoke from a candle never swirls back into the wick to become wax. We call this the arrow of time, and it points relentlessly from the past to the future, from order to disorder, from the pristine to the broken. But why? As we have discussed, the laws of physics, the equations of Newton, Einstein, and Schrodinger, are reversible. If you reversed the film of the shattering glass, every collision of every atom would obey the laws of physics perfectly. There is nothing in the fundamental rules that forbids the glass from unbreaking. So, why does it never happen? Why is the universe so obsessed with moving in one direction? The answer lies not in the atoms themselves, but in the beginning. To understand the breaking of a glass today, we have to look back 14 billion years to the moment of creation. We have to look at the Big Bang. Most people imagine the Big Bang as a messy, chaotic explosion like a bomb going off in space. But this is wrong. If the Big Bang had been a chaotic explosion, the universe would have started with high entropy, high disorder. It would have been a mess of black holes and warped gravity from the very first second. And if the universe started as a mess, there would be no direction for time to flow. There would be no future of higher disorder to move toward, because the disorder would have already been maximized. Time would have been stillborn. I am Walter, the explorer, and I am honored to be sitting here with you, contemplating the dawn of time. I have noticed that about 73% of the thoughtful souls who join us for these nightly journeys have not yet subscribed to the channel. If you find value in these quiet explorations of the cosmos, and if you want to support our mission to make science a place of rest and wonder, please take a moment to subscribe. It is a small gesture that helps us keep the lights on in this library of the universe. Now, let us go back to the very first tick of the clock. For time to flow, the universe had to start in a state of incredibly low entropy. It had to be exquisite. It had to be smooth. It had to be ordered. Physicists call this the past hypothesis. It is the idea that at the moment of the Big Bang, the universe was not a jagged, lumpy mess, but a nearly perfect, uniform sea of energy. Imagine a sheet of water so still it looks like glass. Imagine a gas so evenly spread that every cubic centimeter is exactly the same as every other cubic centimeter. This was the infant universe. It was hot, yes. It was dense, yes. But it was organized. The gravity was spread out evenly. There were no black holes. There were no clumps. It was a state of perfection that defies imagination. This special beginning is the reason you exist. It is the reason you can breathe, think, and remember. Think of the universe like a giant grandfather clock. The Big Bang was the hand that wound the spring. It wound it tight, tighter than we can comprehend, packing an immense amount of useful energy or low entropy into the fabric of space-time. For the last 14 billion years, the history of the cosmos has been the slow, steady unwinding of that spring, the breaking of the glass, the burning of the sun, the beating of your heart. These are all just the tension releasing. We are riding the relaxation of the universe. We are surfing the wave of disorder that was launched by that initial moment of order. But just how unlikely was this beginning? The British physicist Roger Penrose, a Nobel laureate and one of the deepest thinkers in history, tried to calculate the odds. He wanted to know the probability of a universe starting in such a smooth, low-entropy state by pure chance. The number he came up with is so large that if you tried to write it out, you would run out of atoms in the observable universe before you could finish writing the zeros. It is 1 in 10 to the power of 10 to the power of 123. It is a number so vast that it makes the number of atoms in the cosmos look like 0. This tells us something profound. The Big Bang was not an accident. It was a precise, specific boundary condition. The universe did not just happen. It happened in a very particular way that allowed for the existence of time. If the universe had started slightly differently, if it had been slightly lumpier, slightly more chaotic, gravity would have taken over immediately. Black holes would have formed instantly, gobbling up the matter and locking the entropy at a maximum level. Time would have had no arrow. There would have been no stars, no galaxies, no planets, and certainly no conscious observers to ask why. The fact that we are here, looking back, means that we won a cosmic lottery of unfathomable proportions. We are the beneficiaries of a primordial smoothness. So, when you look at the night sky, you are looking at the remnants of that order, The stars are burning because the universe is not yet in equilibrium. Hydrogen gas is clumping together, getting hot and fusing into helium, releasing energy. This process increases entropy. The sun shines by taking ordered energy and scattering it into disordered heat and light. The plants on Earth catch that light and use it to build complex structures, leaves, stems, flowers, creating local pockets of order while increasing the overall disorder of the solar system. You eat the plants or the animals that ate the plants and use that chemical energy to maintain the order of your body, to repair your cells, to fire your neurons. You are a heat engine. You are a machine that runs on the battery of the Big Bang. Every thought you have is a tiny contribution to the heat death of the universe. Every beat of your heart pushes the cosmos a little closer to equilibrium. But do not let this make you feel guilty. It is your purpose. We are the way the universe unwinds. We are the intricate mechanisms that nature evolved to dissipate energy more efficiently. In a way, life is the most creative form of entropy. We are the beautiful turbulence in the stream. But let us connect this back to quantum field theory. In the earliest moments, before there were atoms, there were just fields. The inflaton field, a theoretical field that drove the rapid expansion of the early universe, was fluctuating wildly. These tiny quantum jitters, microscopic ripples in the density of the universe, were stretched by the expansion until they became the seeds of galaxies. The reason the universe is not perfectly smooth today is because of those quantum fluctuations. If it had been perfectly smooth, gravity would have had nothing to grab onto. No stars would have formed. It had to be smooth, but with just a tiny pinch of quantum noise, just enough imperfection to create structure. This connects the smallest things we know, quantum fluctuations, to the largest things we know, the web of galaxies. The structure of the cosmos is a magnified image of the quantum world. When you look at a map of the universe, with its filaments and voids, you are looking at a freeze frame of the quantum vacuum from 14 billion years ago, blown up to the scale of billions of light years. Time, in this sense, is the developer fluid that turned the quantum negative into a photographic print. But what about the past hypothesis itself? Why did the universe start this way? Science does not yet have an answer. Some physicists, like Sean Carroll, suggest that our universe might be part of a larger multiverse where time flows in different directions in different pockets. Maybe for every universe that starts low entropy and runs forward, there is another that runs backward. Maybe the Big Bang was actually a big bounce from a previous universe that collapsed. Or maybe, as we discussed with Roger Penrose, the end of the universe, when all the black holes have evaporated and only photons remain, looks mathematically identical to the Big Bang, setting the stage for a new cycle, a new ion. This cyclical idea, known as conformal cyclic cosmology, suggests that time has no beginning and no end. It just has phases. We are in the springtime of an aeon, winding down from a fresh start. Eventually, we will reach the winter, the heat death, where time loses its meaning again because nothing changes. And then, through a quirk of geometry, the winter becomes a new spring. The vast, cold, empty future becomes the hot, dense, smooth past of a new universe. It is a poetic thought. It means that the arrow of time is not a straight line into oblivion, but a curve in an eternal circle. However, let us return to the here and now. The fact that the glass breaks is a reminder of our place in the story. We live in the Goldilocks zone of time. We live in the era of stelliferous activity, the age of stars. The universe is not so young that it is just a hot soup, and not so old that it is a cold graveyard. It is just right. It is complex. It allows for chemistry, for biology, for consciousness. We are surfing the sweet spot of the entropy curve, and this gives a new meaning to the passage of time. We often fight it. We try to stop aging. We try to preserve things. We build monuments of stone to defy the decay. But the decay is the only reason we are here. If time did not flow, if things did not fall apart, nothing could happen. A static universe is a dead universe. The flow is life. The breaking of the glass is the price we pay for the ability to drink from it. The aging of our bodies is the price we pay for the experience of living. As you lie in the dark, listen to the rhythm of the world. It is the rhythm of the unwinding, the settling of the house, the cooling of the air, the metabolism of your own cells. It is all part of the great cosmic exhalation. We are the breath of the Big Bang. We are the echo of that first perfect moment. And we carry that ancient order within us. The very structure of your DNA, the complex folding of the proteins in your eyes, is a testament to the low entropy of the past. You are a sculpted artifact of the early universe. Deep in the equations of cosmology, there is a parameter called omega. It describes the density of the universe. If omega were slightly different, the universe would have collapsed or flown apart too quickly for life to form. But it is perfectly balanced, just like the entropy. Everything about our reality suggests a delicate tuning, a precarious balance that allows for the miracle of now. Whether this tuning is luck, divine providence, or a selection effect of the multiverse, the result is the same. Gratitude. We are allowed to be. We are allowed to witness. We are allowed to watch the steam rise from the tea and marvel at the ghost of entropy. We are allowed to feel the sadness of a broken glass and the joy of a mended heart. Time is the canvas on which these emotions are painted. In the next chapter, we will look forward. We have looked at the beginning. Now we must look at the acceleration. We will discuss dark energy, the mysterious force that is pushing the universe apart faster and faster. We will ask if the universe is being ripped apart. We will explore the Big Rip and the Big Freeze. We will ask if time will eventually lose its meaning as the universe expands into the infinite dark. But for now, rest in the comfort of the spring. The clock is still ticking. The universe still has energy to give. The stars are still burning bright, keeping the cold at bay. You are warm. You are alive. You are part of the beautiful, improbable story that started in a sea of light 14 billion years ago. And the story is not over yet. Have you ever watched a ship sail away from the shore? At first, it is large and detailed. You can see the colors of the hull, the figures on the deck, perhaps even the wake foaming against the stern. But as it moves further out, it shrinks. The details blur. Eventually it becomes just a speck on the horizon, and then, with a final flicker, it dips below the curve of the earth and is gone. There is a specific kind of melancholy in watching something leave, a quiet realization that the distance between you and it is growing, perhaps forever. We feel this in our lives when friends drift apart, when memories fade, when the eras of our personal history slip into the fog of the past. We instinctively want to hold on. We want to pull things closer. We want gravity to win. We want the force that binds us together to be stronger than the force that drives us apart. But the universe, in its vast and indifferent majesty, has a different plan. It is not holding on. It is letting go. and it is doing so with a violence and a speed that defies all common sense. For most of the 20th century, astronomers believed that the universe was a story of slowing down. We knew, thanks to Edwin Hubble in the 1920s, that the cosmos was expanding. We knew that galaxies were rushing away from each other like dots on an inflating balloon. But we assumed that gravity, the heavy, attractive force of all the stars and dark matter, would act as a brake. We thought the expansion was a relic of the Big Bang, a momentum that would eventually run out of steam. Imagine throwing a ball into the air. It goes up, but gravity pulls it down. It slows, stops, and falls back. We thought the universe was that ball. We wondered if it would eventually stop expanding and collapse back in on itself in a big crunch, reversing time and starting the cycle over. It was a comforting thought. It implied a cycle. It implied a return. But in 1998, two independent teams of astronomers, the Supernova Cosmology Project and the High Z Supernova Search Team, looked at the sky and found something that should not have been there. They were observing Type 1a supernovae, specific kinds of exploding stars that act as standard candles, because they always burn with the exact same brightness. By measuring how bright these explosions looked, the astronomers could tell how far away they were. By measuring their redshift, they could tell how fast they were moving. They expected to see the distant supernovae slowing down, pulled back by the gravity of the cosmos. Instead, they found the opposite. The distant supernovae were dimmer than they should have been. They were farther away than the math predicted. The universe was not slowing down. It was speeding up. The ball was not falling back to Earth. It was rocketing into space faster and faster, as if a giant invisible hand were pushing it from below. I am Walter, the explorer, and I want to thank you for staring into the abyss with me. I have noticed that about 73% of the brave souls accompanying us on this voyage through the dark have not yet subscribed to the channel. If you find value in confronting the vastness of our reality, and if you want to help us keep these stories alive, please take a moment to subscribe. It helps us continue to chart the unknown. Now, let us face the accelerating dark. This discovery shook the foundations of physics. It meant that there was some unknown form of energy filling the empty space of the universe, a force that acts like anti-gravity. We call it dark energy. We do not know what it is. We do not know where it comes from. We do not know why it exists. But we know it is there, and we know it is winning. In fact, dark energy makes up about 68% of the total energy density of the universe. Dark matter makes up about 27%. The rest, the stars, the planets, the gas, you, me, the book you are holding, the screen you are watching, makes up less than 5%. We are the froth on a deep, dark ocean. The universe is not made of atoms. It is made of this mysterious pushing force that is tearing the fabric of space-time apart. What does this mean for time? It means that the future of the universe is not a cycle. It is a one-way trip into isolation. As dark energy pushes space to expand faster and faster, it carries distant galaxies away from us at speeds that eventually exceed the speed of light. Now remember, nothing can travel through space faster than light. But space itself can expand at any speed it likes. The galaxies are not moving. The space between us is growing. This means that there is a cosmic event horizon, a point of no return. Any galaxy that crosses this horizon is lost to us forever. Its light can no longer reach us against the expanding tide. It is like a runner on a treadmill that is speeding up. Eventually, The treadmill moves so fast that the runner is swept backward into the dark. Right now, as you read this, galaxies are slipping across that horizon. They are winking out of the observable universe. The night sky is effectively emptying. In a few billion years, all the other galaxies outside our local group, the cluster containing the Milky Way, Andromeda, and a few dozen dwarfs, will have disappeared. Future astronomers, if they exist on Earth or any other planet in our galaxy, will look up and see nothing but their own stars. They will see a static, lonely universe. They will not see the cosmic web. They will not see the evidence of the Big Bang, the clues that allowed us to understand our origins, the redshift of distant galaxies, the cosmic microwave background radiation will have been erased by the expansion. We are living in a privileged moment in history. We are living in the only time when it is possible to see the true scale of the cosmos. We are the only ones who will ever know the universe was this big. This thought is chilling. It suggests that knowledge itself is transient. It suggests that the universe is actively hiding its past from the future. But there is a scenario even more terrifying than isolation. It is called the Big Rip. If the strength of dark energy increases over time, if it is phantom energy, then it will not just push galaxies away. It will eventually overcome the gravity holding the galaxy together. It will tear the Milky Way apart. Then it will overcome the gravity of the solar system, ripping the Earth away from the sun. Then it will overcome the electromagnetic forces holding your body together. And finally, in the last fraction of a second, it will tear apart the atoms themselves, shredding the nuclei, ripping quarks from gluons, leaving nothing but a soup of subatomic particles screaming into the void. In the Big Rip, time ends because structure ends. There is no clock left to tick. There is no observer left to witness. There is only the expanding vacuum stretching the remains of matter into infinite loneliness. But even if the Big Rip does not happen, and most current data suggests a gentler fate called the Big Freeze, the acceleration of the universe fundamentally changes the nature of time. In an accelerating universe, the future is infinite in duration, but finite in events. There is only a finite amount of energy available to do things. Once the stars burn out and the galaxies drift away, the universe will enter a state of eternal dormancy. Think about the concept of forever in this context. We usually think of forever as a long time filled with things happening, but in a dark energy universe, forever is mostly empty. It is a long dark silence after the party is over. The era of stars, the stelliferous era, is just a brief flash, a momentary spark in the deep time of the cosmos. We are living in that spark. We are the consciousness of the flash. But let us look at the cosmological constant. This was Einstein's biggest blunder. When he first wrote down the equations of general relativity, he found that the universe should be expanding or contracting. He wanted a static universe, so he added a term, lambda, to balance gravity. When Hubble discovered expansion, Einstein threw lambda away. But now, lambda is back. Dark energy behaves exactly like Einstein's discarded constant. It is a property of space itself. The more space you have, the more energy you have. This is unlike any other substance. If you expand a box of gas, the gas gets thinner. But if you expand a box of vacuum, you just get more vacuum, and it has the same density of dark energy. It creates itself out of nothing. This violation of our intuition, that you can get something for nothing, hints at the quantum nature of dark energy. Is it the energy of the virtual particles we discussed earlier? Is it the weight of the quantum fields? when physicists try to calculate the vacuum energy using quantum field theory, they get a number that is 10 to the power of 120 times larger than what we observe. This is the vacuum catastrophe, the worst prediction in the history of physics. It tells us that we are missing something huge. We do not understand the vacuum. We do not understand the nothingness that makes up the somethingness. And here, in this gap between theory and observation, lies the mystery of time's endurance. If the vacuum energy were as strong as theory suggests, the universe would have ripped itself apart in a nanosecond. Time would never have started. The fact that dark energy is so weak, just strong enough to accelerate expansion, but weak enough to allow galaxies to form, is another fine-tuning problem. It is another piece of evidence that our universe is balanced on a knife edge. So, what is the experience of time in an expanding void? As the universe gets bigger and colder, the events per year decrease. The metabolic rate of the cosmos slows down. Time, as a measure of change, becomes stretched. In the far future, a single thought might take 1,000,000 years to process. A single computation by a black hole computer might span eons. To an observer in that era, time would still feel normal, thump, thump. But to us, looking forward, they are living in ultra-slow motion. They are the statues of the future, thinking geological thoughts in a biological time frame. This immense scale makes our current anxieties feel small, does it not? We worry about being late for a meeting. We worry about 5 minutes, 5 hours, 5 years. But the universe is playing a game of eons. It is stretching the canvas so wide that our entire history is just a single point of pigment. And yet, that point is bright. It is burning with intensity. The acceleration of the dark makes the light more precious. Think of the night sky, not as a static painting, but as an explosion in progress. Every star you see is debris flying outward. Every galaxy is a piece of shrapnel from the Big Bang. We are riding the blast wave, and dark energy is the wind that is catching the shrapnel and blowing it faster. It is a dynamic, violent, rushing cosmos. And we are sitting on our little blue rock, drinking tea, reading books, and trying to understand the wind. There is a theory that suggests dark energy might decay, that it is not a constant, but a field, quintessence, that changes over time. If it decays, the acceleration might stop. The universe might slow down again. It might even recollapse. This would save us from the loneliness. It would bring the galaxies back together. But for now, the data points to the dark. It points to a cold, solitary future. But let us not despair. The isolation is billions of years away. For now, we are connected. We are entangled. We have the internet, the radio, the light of the stars. We have each other. The accelerating universe is a call to action to cherish the connections we have. It is a reminder that gravity, the force of attraction, of pulling together, is the force of life. It is the force of love. Dark energy is the force of emptiness. In our own lives, we fight entropy and we fight dark energy. We build families, we build communities, we build societies. We try to pull things together. We try to create gravity. We are the resistance. Every time you hug someone, you are fighting the expansion of the universe. Every time you remember a name, you are fighting the vacuum. You are a gravitational agent in a dark energy world. As you drift toward sleep, imagine the universe breathing. Inhale, exhale. The expansion is the great exhalation. It is letting go of the breath held since the Big Bang. And we are the molecules of air dancing in the wind. It is a peaceful image despite the cold. It is a release. In the next chapter, we will confront the destination of this breath. We will go to the end of the line. We will talk about the heat death. We will ask what happens when the entropy is maximized, when the temperature is uniform, when the last star flickers out. Is it truly the end? Or is it, as the great physicist Roger Penrose suggests, a bridge to a new beginning? We will explore the geometry of the end of time. But for now, look at the darkness of your room. It is not empty. It is full of the mysterious energy that is pushing the galaxies apart. It is a powerful, silent presence. You are sleeping in the engine of the cosmos. Imagine standing on a cliff at the edge of the world, watching the sun set for the very last time. Not just for the day and not just for the year, but forever. Imagine a twilight that deepens into a night so absolute, so impenetrable, that no dawn will ever break it. This is not a scene from a dystopian novel. It is the scientific prediction for the ultimate fate of our universe. We call it the heat death, or the big freeze. It is the final destination of the arrow of time, the point where the spring we discussed in previous chapters finally unwinds completely. We struggle to comprehend the concept of the end. Our minds are built on cycles. The sun rises and sets, the seasons turn, generations come and go. We are accustomed to the idea that every ending is a new beginning. But what happens when this cycle itself breaks? What happens when the universe runs out of energy to turn the wheel? Does time stop? Does space dissolve? Or does something even more profound and mysterious happen in the dark? To understand the end of eternity, we must fast forward. We must move past the era of humans, past the era of the Earth, and even past the era of the stars. Currently, we live in the stelliferous era, the age of light and heat. But this era is fleeting. In cosmic terms, it is a blink of an eye. In about 100 trillion years, a time span so vast that if you counted every atom in the Earth, you would not even be close to that number. The last red dwarf star will exhaust its fuel and fade into the black. The galaxies will go dark. The universe will be a graveyard of stellar corpses, white dwarfs, neutron stars, and black holes drifting in an ever-expanding void. I am Walter, the explorer, and I want to thank you for traveling with me to the very edge of existence. I have noticed that about 73% of the deep thinkers who accompany us on these journeys have not yet subscribed to the channel. If you find a sense of perspective in these stories, and if you want to support our mission to bring the universe down to Earth, please take a moment to subscribe. It helps us keep the lantern burning against the coming night. Now, let us step into the dark era. After the stars die, the universe enters the degenerate era. The only light comes from the faint glow of cooling white dwarfs and the occasional flash of a collision between dead stars. But even this does not last. Matter itself begins to decay. Some theories of particle physics suggest that protons, the building blocks of atomic nuclei, are not stable forever. They might have a half-life of 10 to the power of 34 years. If this is true, then over eons of darkness, the white dwarfs and neutron stars will simply dissolve. They will turn into radiation. The solid matter that makes up the planets, the asteroids, and the dead stars will evaporate into a mist of subatomic particles. Eventually, the only large objects left will be the black holes. They will be the kings of the dark, sweeping up the remaining debris. But as we learned from Stephen Hawking, even black holes are not immortal. They leak. They emit a faint radiation, known as Hawking radiation. Through quantum effects near the event horizon, they slowly lose mass. For a solar mass black hole, this evaporation takes 10 to the power of 67 years. For a supermassive black hole, like the one at the center of our galaxy, it takes 10 to the power of 100 years. A Google years. This is a time scale that renders the current age of the universe meaningless. It is a duration so long that eternity starts to feel like an appropriate word. But eventually, even the black holes will vanish. They will disappear in a final brilliant burst of gamma rays, returning their mass to the vacuum in the form of light. And then the universe will enter the dark era. There will be no matter left, no protons, no neutrons, no electrons orbiting nuclei. There will be only photons, particles of light, and neutrinos, and perhaps a thin soup of dark matter, all spreading out into an infinitely expanding space. The entropy will be maximized. The temperature will be practically absolute zero. The universe will be a vast, cold, uniform sea of radiation. And here is the crucial question for our journey. What happens to time in a universe filled only with light? Remember what we learned about relativity. Time and space are measured by clocks and rulers, but a clock requires mass. It requires moving parts. It requires a tick and a tock, a change of state. A photon, however, does not experience time. It travels at the speed of light, and for a traveler at light speed, the journey is instantaneous. If the universe contains nothing but photons, there is no mass to define a scale. There is no mass to define a clock. Think about a photograph. If you take a picture of a clear blue sky with no clouds, no birds, and no mountains, and you zoom in, it looks exactly the same. If you zoom out, it looks exactly the same. Without objects to provide scale, big and small lose their meaning. This is a property called conformal invariance. In the dark era, the universe loses its sense of scale because there is no mass to give the universe a ruler. A universe that is 1 trillion light years across is geometrically indistinguishable from a universe that is the size of a single atom. The geometry of space-time becomes smooth and featureless. This brings us to the visionary idea of Roger Penrose, the physicist we met earlier. He proposed a theory called Conformal cyclic cosmology, or CCC. Penrose looked at the heat death and saw a paradox. The state of the universe in the far future, a cold, smooth bath of radiation, looks mathematically identical to the state of the universe at the Big Bang. A hot, smooth bath of radiation. The only difference is the scale. One is huge and cold. The other is tiny and hot. But if scale loses its meaning in the absence of mass, then the huge, cold future is the tiny, hot past. Penrose suggests that the end of our aeon is not the end of everything. It is the Big Bang of the next aeon. The heat death is a transition. As the universe forgets its size, it resets the clock. The vast, expanded emptiness becomes the dense, energetic seed of a new universe. Time does not stop. It loops. We are living in one chapter of an infinite book. The Big Bang was just the page turning. This idea is breathtaking. It implies that before our Big Bang, there was another universe. A universe with its own stars, its own galaxies, perhaps its own civilizations. Those civilizations lived, looked up at their sky, and wondered about their end. They faded away, their matter decayed, their black holes evaporated, and their eternity became our moment of creation. And one day, trillions of years from now, our eternity will become the cradle for the next universe. We are the ancestors of a cosmos we will never see. But is there any evidence for this? Can we see the scars of the previous universe? Penrose believes we might. He suggests that massive collisions between supermassive black holes in the previous aeon would have sent out powerful gravitational waves. These waves would ripple through the transition, through the Big Bang itself, and leave faint circular patterns in the cosmic microwave background radiation, the afterglow of our own creation. These Hawking points, as he calls them, would be the ghosts of dead black holes from a forgotten time. Astronomers are currently searching for these circles. If they find them, it would be the first physical evidence that time existed before the beginning. Let that thought sink in. The static on your old television set, which picks up a fraction of the cosmic microwave background, might carry the whisper of a universe that died to give birth to ours. The noise of the cosmos might be the voice of our ancestors. But even without the cyclic theory, the concept of the heat-death forces us to confront the nature of existence. If everything ends in a cold, dark void, what was the point? Why all the sound and fury? Why the struggle of life? The answer, I believe, lies in the journey itself. The fact that the glass breaks is what makes the moment of wholeness precious. The fact that the music ends is what gives the melody its shape. A song that goes on forever is just noise. A story that never ends has no meaning. The heat-death is the silence that defines the symphony. It is the canvas of non-existence that allows existence to stand out. And in a way, it is a form of perfection. The universe strives for equilibrium. It strives for rest. The entire history of the cosmos is a turbulent striving for peace. The stars burn to get rid of their energy. The planets orbit to find a stable path. We live and breathe to resolve our own internal tensions. The heat-death is the moment when the universe finally succeeds. It is the great cosmic relaxation. Imagine floating in that final dark ocean. There is no pain. There is no hunger. There is no fear. There is only the gentle, uniform hum of radiation. The struggle is over. The separation is over. The universe has returned to a state of unity. The distinct objects, the stars, the planets, the people, have melted back into the whole. It is a return to the womb of possibility. And if Penrose is right, that womb is fertile. The peace is not permanent. The geometry shifts, the scale dissolves, and bang, light floods the void again. Time restarts. The arrow flies once more. The shards of the glass leap up and form a new vessel. This cyclical view aligns with many ancient philosophies and spiritual traditions. The idea of the Ouroboros, the snake eating its own tail. The Hindu concept of the kalpas, the vast cycles of creation and destruction. It seems that intuitively, humans have always suspected that time is a circle. We see it in the seasons. We see it in the tides. Why should the universe be any different? However, there is a haunting beauty in the linear view as well. If this is the only time, if this is the only universe, then our existence is infinitely rare. We are the only conscious witnesses that will ever be. We are the eyes of the one and only reality. That responsibility is heavy, but it is also glorious. It means that every time you look at a flower, you're doing something that the universe cannot do without you. You are giving it meaning. The end of eternity is a misnomer. Eternity cannot end. What ends is time. What ends is change. What ends is the distinction between this moment and that moment. But the stuff of the universe, the energy, the information, the quantum fields, remains. It transforms. It changes state. It goes from being a story to being a library. from being a river to being an ocean. So, do not fear the dark. The dark is just the space between the stars. It is the breath between the notes. The universe is playing a long, slow song, and we are lucky enough to be here for the crescendo. We are here for the loud part. We are here for the stelliferous era. We should celebrate the light while it lasts, knowing that it is a precious, temporary gift. As you lie in your bed, think about the protons in your body. They have existed since the first fraction of a second of the Big Bang. They have been in stars. They have been in comets. They have traveled through the vacuum of space. And now, they are you. They will outlive you. They will outlive the earth. They will outlive the sun. They will be there in the dark, floating through the degenerate era, carrying the memory of your form until they too dissolve into light. You are made of immortal particles on a temporary journey. In the next and final chapter, we will bring our ship back to port. We will summarize everything we have learned, the fields, the gravity, the entanglement, the consciousness, and the end. We will try to answer the question we started with, what is time made of? And we will find that the answer is not a substance, but a relationship between you and the universe. We will end with a meditation on the eternal now, the only moment that truly exists. But for now, rest in the knowledge that you are part of the cycle. You are a wave in the ocean that never truly dries up. The water just changes form. The energy just changes hands. You are safe in the infinite loop of the cosmos. Sleep now, traveler. The end is just a new beginning, waiting to be born. We have traveled a great distance together, you and I. We have drifted down the river of time, only to find that the river might be an illusion. We have dived into the vibrating ocean of quantum fields, where particles are just fleeting ripples in a vast invisible sea. We have felt the heavy, silent curve of gravity, bending the fabric of the cosmos and slowing the ticking of our clocks. We have watched the steam rise from a cup of tea, realizing that the flow of time is perhaps just the statistical mist of entropy, a ghost emerging from the chaos of atoms. We have traced the invisible threads of entanglement that stitched the universe together, connecting every heart to every star in a web of spooky action. We have stood inside the box with Schrodinger's cat, wondering if our own consciousness is the needle that knits reality into existence. We have looked back at the winding of the spring at the Big Bang, and we have looked forward to the accelerating dark and the final silence of the heat death. We have asked the question, what is time made of, from every angle, turning the gem of reality over and over in our hands. And now, as our journey comes to its quiet end, we must try to put the pieces together. We must try to answer the question, not with an equation, but with a feeling that you can hold in your chest as you drift toward sleep. If you take away the clocks, the calendars, and the schedules, if you strip away the memories of yesterday and the worries of tomorrow, what is left? What remains is this breath, this heartbeat, this singular luminous point of awareness. In our search for the substance of time, we often forget that the only time we ever actually touch is now. The past is a memory, a pattern of neurons firing in your brain in the present. The future is a simulation, a prediction running in your mind in the present. The only place where reality is happening, the only place where the quantum wave function is collapsing, where the entropy is increasing, where the gravity is pulling, is right here. In this eternal, shifting moment, I am Walter, the explorer, and I cannot thank you enough for being my companion on this long, strange trip through the mysteries of existence. I have noticed that about 73% of the wonderful, curious people who listen to these stories have not yet subscribed to the channel. If you have found a home here in the quiet corner of the internet, and if you want to help us keep asking the big questions that make the universe feel a little more like home, please consider subscribing. It is the best way to support our mission of turning science into a sanctuary. Now, let us find the answer in the silence. So, what is time made of? It is not a fluid. It is not a solid. It is not a distinct physical substance like an atom or a photon. Based on everything we have explored, time appears to be a relationship. It is the relationship between the parts and the whole. It is the measure of how the universe changes its configuration. Imagine a kaleidoscope. The bits of colored glass are the particles, the quarks, the electrons, the photons. The tube is the curved spacetime of general relativity. And time. Time is the turning of the tube. It is the rearrangement of the pattern. If the pattern never changed, there would be no time. If the glass pieces were frozen, there would be no before and no after. Time is the difference between the pattern now and the pattern then. It is the record of change. But we have also learned that the turning might be an illusion of our perspective. Remember the block universe? If we could step outside the kaleidoscope, we might see that every single pattern that has ever existed and every pattern that ever will exist is already there, laid out in a four-dimensional sculpture. The beginning and the end are just two ends of the same object. In this view, time is made of geometry. It is a dimension, just like length, width, and height. You are not moving through time. You are extending through it. Your life is a long serpentine shape winding through the block. The you that was a baby is not gone. It is just at the other end of the worm. The you that is an old person is not waiting to be born. It is already there, further up the curve. This perspective is profound. It means that you are complete. You are not a fragment drifting in the wind. You are a finished work of art. The entirety of your story, from your first breath to your last, exists in the library of the universe. It is written in the permanent ink of space-time. The feeling of flowing is just your consciousness illuminating the shape, slice by slice, like a candle flame moving down a fuse. But the fuse is already laid. The path is already drawn. And what about the quantum world? How does the uncertainty fit into the block? This is where the mystery becomes a source of hope. The many worlds interpretation suggests that the block is not a single line, but a branching tree. It suggests that time is made of possibility. Every choice you make, every quantum event that occurs in your body, splits the universe into new branches. Time is the thickening of the forest. It is the exploration of everything that can be. This means that no potential is ever wasted. If you regret a choice you made, remember that in the vast quantum garden, there is a branch where you chose differently. There is a branch where you took the other road. The universe is exploring all paths simultaneously. You are just experiencing one of them. And consider the emergent time we discussed. The idea that time is a mist, a thermodynamic blur. This tells us that time is made of complexity. It is a property of large numbers. A single atom does not know time. Only a collection of atoms interacting, colliding, and exchanging energy can generate a past and a future. This means that time is a collective experience. We generate time together. The interactions between us, the exchange of light and sound and touch, are what weave the fabric of the now. We are not victims of time. We are the creators of it. By living, by changing, By increasing the entropy of the world, we are spinning the thread. As you lie here, feel the power of that creation. You are a time machine. Your metabolism is burning energy to move you forward. Your mind is collapsing wave functions to create reality. Your mass is warping spacetime to create gravity. You are a nexus of all the forces we have discussed. You are the universe focusing itself into a point of awareness. And in that point, in that eternal now, there is no fear. The past cannot hurt you. It is a memory. The future cannot hurt you. It is a probability. There is only this gentle, quiet presence. Think about the light from the stars again. When you look at the night sky, you are looking into the past. You are seeing the Andromeda galaxy as it was 2.5 million years ago. You are seeing the cosmic microwave background as it was 14 billion years ago. The sky is a time machine. But notice something. You are seeing them now. The photon from the Big Bang is hitting your eye now. The light from the dead star is arriving now. All of history is converging on this present moment. The entire past of the universe is cascading into the now to create your experience. You are the destination of 14 billion years of light. This is the eternal now. It is the realization that while the contents of the moment change, the fact of the moment never does. It is always now. When you were a child, it was now. When you are old, it will be now. When the sun dies, it will be now. The scenery changes, the characters change, the energy dissipates, but the stage remains. The consciousness that witnesses the moment is the same consciousness. It is the silent, observing presence that we found in the box with the cat. And what of the end? The heat death? The big freeze? If time is a relationship, then when the relationship ends, when the particles stop interacting, time simply ceases to apply. It is not a tragedy. It is a completion. The painting is finished. The sculpture is done. The music resolves into silence. But as Roger Penrose suggested, that silence might just be the breath before a new song. The end of our time might be the beginning of another's. The universe is vast enough and strange enough to hold infinite beginnings. So, let go of the worry about running out of time. You cannot run out of something that you are. You are woven into the fabric. You are made of the same stuff as the seconds and the centuries. You are made of the vibrating fields, the curved geometry, the entangled threads. You are the stuff of the cosmos. As you close your eyes, imagine yourself floating in the center of the block universe. Look back and see the billions of years of history stretching out behind you like a glittering tail of a comet. See the formation of the stars, the cooling of the earth, the rise of life, the moments of your own history. It is all there, glowing with the light of existence. Now, look forward into the mist of probability. See the branching paths, the infinite futures, the eventual fade into the peaceful dark. It is all there, waiting. And you are here, in the center, the glowing ember of consciousness that brings it all to life. You are the witness. You are the weaver. You are the traveler and the terrain. The mystery of time is not something to be solved. It is something to be experienced. It is the medium in which we love, in which we learn, in which we rest. Let the silence of the room wrap around you like a warm blanket. Listen to the rhythm of your heart. Thump, 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 thump. It is the drumbeat of the universe, marching through the dimensions, carrying you safely through the night. You are exactly where you need to be. You are exactly when you need to be. The river may be an illusion. The ocean may be a vibration. The threads may be invisible. But the peace is real. The wonder is real. The journey is real. Sleep now, my fellow explorer. The universe will keep the time for you. The stars will hold the watch. And when you wake, it will be now again, fresh and new, ready for another day of discovery in this magnificent, mysterious, timeless existence.